Hi, welcome to the first section of this course, Blockchain Foundation. This section, I'm going to lay out the foundation for this course. I'm going to talk about the fundamentals of the blockchain. So as you can see that there are 5 videos. In this video, we're going to talk about the fundamentals of the blockchain, distributed ledger, pay-to-pay networks, blocks, nodes. So I'll try to explain it. If you're a beginner, I'll try to explain it in a way that you understand. If you already have some sort of experience, feel free to, kind of like skip it. So let's get started. So like the first question usually you have to ask, what's a blockchain, right? Like in simple terms, you can pretty much say a blockchain equal a chain of blocks cryptographic linked together, which are immutable and impossible to change after attached to the chain. That's a definition. So if you can see that, okay, you can see that there's a block. The block contains some information or data, whatever it is, and the block is connected to the another block, and that block is connected to the other block, and so on. So chain of blocks. So the first block in the chain is called Genesis block. So just Genesis, as you can understand, it's the starting block. So like the few things here. One is like that they are linked together. Okay, one block, 2 block, 3, 4, 5, and that's fine. So it says that cryptographically linked together. So that means this block has some kind of like you can think of hash, or you can think of a big random number attached to this. And this also has a random number, and of course each block has a random number. But also this block has the previous block random number. So that's what the cryptographically means, because this block holds the information about this block as well. So if you get rid of this block, then what happens is the block 3 has the information about the block 2, but since block 2 is gone, it can't, there's something wrong, like it can't reach block 1, like there's something wrong in the network. So that's what cryptographically means here. So I will talk about what's immutable, what's like what happens if you delete the block here or if you change something in there. But ideally, a blockchain, a chain of blocks, they are linked together cryptographically. So each block has finite number of data parameters, so which are, you can see that block number, nonce, number used only once, some data, payload, whatever data we want to store in that block, and as I said before, previous block hash, right? So each block, this block has previous block hash and this block hash. So since it's the Genesis block, it doesn't have any previous one. These are filled with zeros. But you can see that block 2 has the previous block hash, which is this. This points to this. And similarly for all the blocks, have the previous hash of the block. So we'll talk about each parameter one by one in the next slide. So if you're coming from the CS background, you might be familiar with the linked list. So, it sounds exactly the same. At this moment, we can think it's the same one, but of course it's different. So let's take only the first block. Let's try to understand what each parameter means. So block number, you can pretty much guess the index of the block, right? If it is Genesis block, the block number is 1, then block number 2, 3, 4, and so on. And the block hash, as I said, that each block has a unique queue identifier, right? So this unique queue identifier is generated by a cryptographic algorithm called SHA-256. So we'll talk about this algorithm, in a little later, but you can assume that it's a big random number. That's it. It's impossible to, get the same random number. So just imagine that, that's it. So, and the previous block hash is the same as the current block hash. I mean, it uses the same SHA-256, but it points to the previous block hash. And nouns is probably like one of the important elements in the block, but at this time you can just think it's a 32-bit unsigned integer, like any like 0 to 4 billion. It's a big it could be like sometimes it could be 10, 20, 30, sometimes it could be 2 billion, it's just a 32-bit unsigned number at this time, you can think. But we'll get to that later, like what nouns does exactly. So, and the data field is where we actually store the data. So in the blockchain. So it's up to us, like what kind of data we want to store in the blockchain. So of course, to set the stage right, we store the transactional data mostly because cryptocurrencies and everything, we use transactions. So we mostly use transactions data. But we can pretty much store any data we want, right? Any finance data or healthcare data, or whatever, like you can store any kind of data in the blockchain. So the exact data field contains some metadata of the actual data as well, and of course timestamp. For example, you can as I said, we can store transactional data, transaction 1, transaction 2, transaction 3, and so on, and that data has some timestamp. So and also as I said, you can store any kind of data like record 1, record 2, record 3, and so on. So when I say transaction 1, it actually means A sends B $100, transaction 2, B sends C $50, and so on. So we'll get into that. So yeah, that's pretty much about the blockchain. So it's like if I summarize it, like for example, blockchain is a chain of blocks linked together cryptographically. So each block has some parameters, some data parameters, like data field, nonce field, previous block hash, current block hash, block number, etc., etc. So in the data field, we can store the actual data we want to store in the blockchain. It could be transactional data, it could be health data, it could be finance data, whatever. We can store any kind of data in the block. So now let's talk about the blockchain network. So far we understand what the block is and how that block is connected to the another block. So now let's talk about the blockchain network. What do you mean? What does it mean? Network. So as you know, a network is a collection of computers that are connected together. So just sharing the information from one and another. So blockchain network is also the same. A collection of computers, nodes maintain the same blockchain independently, and of course shares the information of the chain to anyone in the network. So 2 points here. The first point is the same chain, the same blockchain is copied and maintained by every node. So that means you have a blockchain, let's say you have a blockchain of 10 blocks, and so you are in the network. Now some other node comes here. The other node also maintains the same chain or same blockchain that you have, like 10 blocks. So same chain is copied and maintained by every node. So that's the first point. And the second point is a node for one computer can share the entire blockchain information to any other node or any other person, let's say, that is connected to the network. So it's like we are maintaining the same kind of data in our computer, and we can share that data because that entire data is the entire blockchain. So that's what blockchain network is. So as you can see that since you're maintaining the entire copy of the chain, and clearly there is no single person or entity that controls or manages the entire chain. So it's everybody who stores, maintains, and runs the blockchain. So that's what we call a distributed ledger. So a piece of ledger, everybody is storing the same ledger, so that no one can destroy. Some people can destroy their ledgers, but they cannot destroy the other people's ledgers. So that's what we call distributed ledger. As you can see, that's a node A has 4 blocks. Let's say this is the entire blockchain we have right now. Let's say blockchain 1, blocks 1 and 2. So as you can see that node A maintains this blockchain, and node B also maintains the same blockchain. Node C also maintains this same blockchain. So if node C has some wrong data, let's say this block is not there, so that means node C has been corrupted. The node C network, the node C blockchain network has been corrupted because it's not same as node B, node A anywhere. So that's how we detect failures in the network. That's how we just do the entire security, crashing and everything we do over there. So just to give you some idea only, it's a peer-to-peer network. So node A can transfer the entire information of its blockchain to node B, similarly node C or any node in the network. So it's a peer-to-peer network. All right, now let's talk about the immutability. So immutability being unable to be changed. So once a block is attached to the chain, it's not possible to modify or tamper that block. That's what the entire concept. For example, if you put some data in the blockchain network, it's really impossible, highly, to destroy that block or, to modify that block. So as we know that each block has as a cryptographic hash, so that is, a unique random number. So we can use SHA-256 for base, but of course you can use any other cryptographic algorithm also to generate that hash. But I'm gonna just keep on talking about SHA-256, but because Bitcoin uses SHA-256. But if you create a blockchain, we can put any cryptographic hash function to generate the random number. So yeah, each block has an hash. That hash is pretty much unique. If you make a tiny change in that block, in the data or wherever that is, you get a different block altogether. So then the block hash gets calculated by something like this. For example, if you use SHA-256 algorithm, it takes all of these parameters into consideration and it generates a hash. So if you try to change, I don't know, maybe some data, you try to add something in the data, or you try to delete something data, or maybe you change the previous hash or change some number, whatever changes you make in this, you will get completely different hash. So given the same data, you get the same hash. If you make any tiny changes in the data, you will get completely different hash. That's where the whole concept of immutability exists. So if you have the chain, if you have like a bunch of blocks in the network, let's say you have 10 blocks. If you have the more blocks in the network, that means the more security, because it's not possible to go all the way to block 0 and destroy everything. Technically we may destroy it if you have the huge computing power and stuff, but we'll talk about that at attacks and stuff later. But ideally, the bigger the chain is, the better the security. So now let's talk about the consensus. So blockchain is basically a concept, right? It's like we put the data in the blocks and we give the hash to that particular block, or we give the hashes to the blocks and we connect them together. So, and of course, each person maintains the copy of the blockchain. So it's a concept there. Of course, there have to be some high level rules that must be followed by the nodes in the sense, like people who run this, who have the copy of the blockchain basically. So they create the valid blocks, they verify them, they agree on which is the right block, which is the wrong block, and stuff like that. So we need to have a general agreement of the state of the blockchain. So that's where we use the consensus protocols. So any blockchain network needs to have some consensus protocols. So these protocols actually set the stage, and by using these protocols we can pretty much maintain the same state of the blockchain for everybody in the network. So of course, the blockchain network automatically has some sort of automation of verification of blocks and security, but of course even nodes also have to do it's all verifying the blocks, adding data to the blockchain. So we'll talk about that in next videos, even in a couple of next slides. But the concept of consensus protocol is so when you have two blocks added to the chain at the same time, what do you have to do? So that's a problem, right? At the same time, two blocks are created by two different computers and they're added to the chain at the same time. So what do you have to do? So there has to be some pattern. So that's where we use the consensus protocols. So when usually a block is added to the network, for example, let's say we have the so this is the state of the network, or let's say 3 blocks only there in the network. Now let's say node A created a new block, so which has block number 4, previous hash, data announced. So what happens is this node here, when it creates new block, it tells everybody in the network, hey, I have a new block, just it's a valid block, I verified it, and just attach that block to your chain. So now node B and node C, let's say at this time, so they both verified this new block. If new block is valid, then obviously they had it. If the new block is not valid, if they find out, okay, there's something wrong in this block, then of course they reject the block, which means they don't add that to their networks. So it doesn't mean that they reject the entire block. It means that they don't agree to add that block to their network. So of course, if the block is valid, obviously they have no reason to ignore that block. So they add it to the chain, and the chain gets bigger and bigger. They continues to increase. So at a high level, the consensus protocol job is to maintain the security, have the valid have the protocols, rules to verify the blocks, to provide the extra layer of security for the entire network. So in that case, of course, any blockchain network we build, we should have a strong consensus protocols, and of course some sort of automation in the block. So of course, people, nodes don't want to do the entire stuff manually, so the program itself does some sort of automation, like verifying blocks, ignoring or adding. So the nodes or the people who verify the valid blocks or not valid blocks are called miners. So miners are, set of computers or people who constantly observe the blocks coming to the network and they verify it. But why would anyone do this? Because of course they are incentivized to do that, so they get some sort of reward. So we'll talk about that in next videos. So that's what we call like blockchain mining. So mining, in order to maintain this network securely, so the nodes in the network will add, verify, reject the blocks in the network, so maintains the security. Of course they need some sort of incentives in order to do that. So that's where the whole concept of the mining comes into the picture. So the miners will verify the blocks by just solving a cryptographic puzzle. So we'll talk about this cryptographic puzzle a little later. So if the puzzle is solved, of course the block gets added to the network and the miner gets some reward. So it depends on the specifications that are in the blockchain. So a blockchain is set up basically protocols and rules. That's it. So the cryptographic puzzle needs a certain type of hardware and computation to be solved. So it's not something that requires human mind. It requires computer mind and computer hardware power. So yeah, that's pretty much it at a high level. So I'll just try to summarize it. So a blockchain distributed ledger, so copied, maintained by everybody in the network. So it's a peer-to-peer decentralized network. The same ledger is copied, maintained by everybody in the network. So anyone can share the entire blockchain information to anybody in the network. Immutability, once a block is added to the chain, it's not possible to tamper that block or modify that block, because if you try to change it, the state, the hash will change, and the following blocks don't agree with that hash. So we use SHA-256 as a cryptographic algorithm function to generate the random number as a hash. But of course we can use any hashing functions, but 256 is pretty much famous one. So we'll require consensus protocols to agree the state of the blockchain. So that's where we use consensus protocols. We'll talk about the consensus protocols in the coming videos. Like we have two, proof of work and proof of stake. We'll cover both of them. And we need to have some incentive system in the blockchain, because people who can validate, verify the blocks, who can give some extra security to the net, will need some kind of reward. So that's where the miners come into the picture. Yeah, that's pretty much it. Like at a high level, we just discovered, we just basically understood what blockchain is, how it works, what kind of things it requires, how this works. Now one by one we'll slowly cover these, we'll slowly try to understand, deep dive into these concepts. So the next video I'll talk about the cryptographic fundamentals, just to give you some sort of understanding, like how this hash gets calculated, how this thing entire works. All right, I'll see you in the next video.